Good day, everybody, and once again, welcome back to Everything Mathematics, where today we're going to continue on video 3 of 5 of this week's video series. Today is Wednesday, and today we'll be looking at types of angles. I noticed that this angle here was removed from here. However, that happened, I don't know. So today we're going to be looking at the types of angles, and what is our objective? Basically, we have to be able to define an angle, and we also have to be able to define and identify the various types of angles. So in today's videos and tomorrow's videos, God willing, we're going to be doing just angles. Tomorrow we have the activity. Today I'm going to just lay the foundation. Well, tomorrow, God willing, of course, if we live. So first of all, what is an angle? An angle is basically a measure of turn from a point of reference. Note, angles are measured in either degrees or radians. If you're using degrees, you would see something like this, like a little zero in front of above the number. So this is 8 degrees. Let me use that on my so it goes some better. 8 degrees. And radians, if an angle is measured in radians, you usually see pi. So I could have 60 pi, let's say, or pi over something. You have 2 pi. You have pi over what? 4, and so on and so forth. And this is a very interesting unit. Maybe I could tell you off the bat, pi is 180 degrees. So when you're converting, that is one of the things that would help you. But we ain't going to look at the conversion today. Just know that you have two means of 2 units in which we use to measure angles. And let's just go back a little and play with the definition. A measure of turn from a point of reference. So the easiest way to illustrate that, remember, if we have a line like this, and this line, let's say, is folded and you bring it up, so let's say to form this angle, we can say that this line, the dotted line, was moved from the flat line to go right up to where I stopped there. So it's a measure of turn from a point of reference, and my point of reference is this point here, which we often consider or call the vertex. So the vertex is our point of reference, and this line can move any amount of times you want it to move, or to any amount of degrees or radians. But that's what you need to know. The easiest example to look at this also, think about a window who is hinged to a wall. So the point of reference of a window, or the angle of reference of a window, is the hinges. And from the hinges, we could open it and close it to whatever number of degrees we want. Well, not whatever. Most windows may not be able to open to 180 degrees, but as much as you want it. And a door also. A door is a nice point of reference for an angle. Every time you open a door, you have some hinges holding up the door, which is your vertex sort of, your point of reference, and your angle of the door could open to, as you know, any amount of degrees that you desire. Well, of course, in real life, we're not so drastic. We don't open doors to specific degrees. We just say open the door, open it a little, leave it a little closed. I've heard half open, half closed, whatever the case may be. But yes, in reality, mathematically speaking, yes, we could open a door to certain measures of turn, and that would be our degree, thus forming an angle, or radians, of course. The types of angles that we should be known, or that we should know or be aware of are these 5 angles here: acute, right, obtuse, straight, and reflex. So let's see how quick we could go through this so that we could make a short video today. You could always again pause, take down definitions, digest it, and move on. So what is an acute angle? An acute angle is any angle that measures more than 0 degrees but less than 90 degrees. And an illustration for that are all these. And I usually tell students it's always wise to keep as a point of reference what a 90-degree angle look like, and also what a 180-degree angle look like. So this says 180 degrees, which we will see just now. This is a straight angle. Don't mind me jumping the gun, but I think this is common knowledge. And this angle here is 90 degrees angle. So acute will always be pretty much when you close a 90-degree angle. So any angle formed when you close a 90-degree angle, if that makes better sense for you, I don't know, is whatever works for you. So if you close it, you make an acute angle. meaning that this angle will be less than 90 degrees. So at this point here, we know that this is 90 degrees. But obviously, if I just go 1 degree to the right, let's say, so the minute I step into 89 degrees, we have an acute angle. And that is what this definition is saying here. An angle that measures more than 0 but less than 90. Oh yes, and key to note, when we are right here, we are at 0 degrees. So the minute I go up at 2, right? The minute I go up a little thing B, one little dot, whatever I want to call it, 1 degree. So from 1 degree to 89 degree, any angle within that range would be considered an acute angle. Make sure you understand this because it will play off tomorrow. That's really in our activity. Good. What is an right angle? Pretty much just told you. It's an angle that is exactly 90 degrees. And here we have 2 examples. So we have this one here, and here we have several ones in different orientation. And it's very wise also to know them in various orientation. I know oftentimes students believe that a right angle is an angle that is either this way or an angle that is this way. But no, it doesn't have to be. A right angle could be this way too. Yes, a right angle could be this way too. Or what about this way? Right? So long as you have that L shape, oh, that's what I'm coming out from the tongue today. L shape. Once we have an L shape, we have a right angle triangle. Sorry, a right angle being formed. And right angle is simply another word for 90 degrees. Obtuse angle, again, we have a 2 points of reference here, 90 degree, 180 degree. So remember we said earlier, this is what a generally 90 degree angle look like, and this is generally what 180 degrees look like. So an obtuse angle will be an angle that is more than 90, oh, not right, 99. This is 90 degrees. So an obtuse angle is an angle that is more than 90 degrees but less than 180 degrees. So it wouldn't step down all the way to 180. It would stay above. So the highest obtuse angle technically is 179 degrees and the lowest will actually be 91 degrees for what it was. And we need to know what they look like. These are examples of what obtuse angle look like. They are more than 90 but less than 180. So they could open out, they could come to be very close to flat, but it cannot be flat. Because if it's flat, guess what? We have a straight angle. And a straight angle is exactly when it is flat. This is a straight angle, 180 degrees. And of course, you could get used to seeing it in different orientations too. So a right angle is, a straight angle is basically a line segment. If you think of any line segment or a line, you have a straight angle. And some persons sometimes wonder, why is it a straight angle? Why is a line a straight angle? Think about it. I mean, it's pretty straightforward. Supposing you have a point, supposing you have a line here. If you go to open this all the way to over here, so imagine you just open it, you open it, you open it, you open it, you open it, until you reach the other side. Good. We have a 180. So yes, a 180 could be 2 parts being open, because remember, we must have, and that's what's critical, we must have a point of reference, which we called earlier the vertex. So once that happens and we reach this position, we have what we call a straight angle. That's what it is. That's what it is. And reflex angle, again, simple. It's an angle that measures more than 180 but less than 360 degrees. So more than 180, less than 360. And this is how we demonstrate it. So remember, right here is a straight angle. This here was a straight angle. So the minute we cross that, we now entering into the reflex region. So this angle is very flexible. It passed 180, if that makes sense. And here we have another way to show it. So here we have another example. And you have to be aware of the notations for them. So in this case, we have this curve here. So this curve obviously is the wider side, because this side would have been 180. From here to here would have been 180. And this is evidently more than that. So once it's more than 180 but less than 360, we have a reflex angle. And it's wise to know this opposite side. I won't tell you the degrees, but you have to be able to see that that is an obtuse angle. Obtuse simply because it is more than 90, because remember, around here, so let's say, would have been our 90 degree. So this here is more than 90, but definitely less than 150. So that's our obtuse. And I have a bonus here for you. It's not a type, well, it's not, it's kind of a type of angle, but I mean, we don't really talk much about this one, but I mean, you have to know it, a complete turn or a revolution. It usually comes to play with angles too, although it's not, I wouldn't call it a type of angle, but I don't know, maybe it is. But you should know what it is. A complete turn or a revolution is basically 360 degrees. So I remember the other time in Form 1, I was teaching them this and I asked them, if somebody spins 300 and, no, I lie. I didn't give them the degree. I use the word revolution. I tell them they were spinning and they made 5 revolutions. How many degrees did they turn? And yeah, some of them were able to pick it up. At the time when I was teaching this, I remember the movie Dancing Revolution came out. And to hell, some of them just couldn't see a revolution at 360 degrees. They thought it was a dance movie, which it was. But again, you could have seen the relationship. One of the things that a lot of people know by default is a 360. You know, it's like you make a 360. It's like you go right. Well, I don't know. Sometimes they say it, but they don't make the connection. But yeah, usually that is something we say. If you make a 360, like you make a complete turn. If you start it facing north, you turn and you end up facing north again. A complete turn. But yeah, that's what it is. So yeah, that will bring us to the end of today's video. As always, like, share, subscribe if you haven't as yet. Comment if there's anything that wasn't clear for you. I will gladly address it to help you out any way I could. And turn on that notification so you can continue to get videos as we grow this channel. Our aim is to reach 1,000 subscribers. Whenever that happens, it happens. But it's about everything mathematics. Tomorrow, God willing, we'll be looking at different examples and at 2 different activities as to how we could associate angles or identify angles. And then we move on to supplementary and complementary angles to wrap up this week. So until then, see you. Take care.